In a previous section, we discussed derivative shortcut rules for our 6 trigonometric functions. We are going to make use of those in this section when we talk about derivatives of inverse trigonometric functions. Now there are a total of 6 inverse trigonometric functions. I would like to start, as we typically do, with the arcsin, or the inverse sine of x. We're going to be applying the same 4-step process as what we did in the previous video. So we'll start by pointing out that for the inverse sine function, or arcsin function, that would be the inverse of the sine function. So determine the original function. Next up, we differentiate the original function. F prime of x would be equal to the cosine of x. Step 3, we actually plug in the inverse function. So this would be the cosine of the inverse sine of x. Now before we go on to step 4, I actually wanted to address this situation. When it comes to trigonometric functions, like a cosine, the input is supposed to be an angle and the output is supposed to be a ratio. For an inverse trigonometric function, the input is the ratio and the output is supposed to be the angle. Which means that the inverse sine of x can also be expressed in terms of an angle. I'm going to refer to it as theta for the time being. Now, if theta is equal to the inverse sine of x, this is equivalent to saying that the sine of theta is equal to x. Or going back to SOHCAHTOA, that would be like saying x over 1. Now, I can draw that as a right triangle. If we put a right angle here and theta here, then according to the SO of SOHCAHTOA, sine is opposite over hypotenuse. Opposite side would be x, hypotenuse would be 1. Once you know two sides of a right triangle, there's a very natural thing to do next, which would be to apply the Pythagorean theorem to determine that third side. So we'll treat a as our unknown side here. So a squared plus x squared is going to be equal to 1 squared. We are solving for a. Nope, no square root yet. Haven't done a square root. My bad. So a would be equal to, generally we would see plus or minus a square root. However, based on the quadrant restriction of the inverse sine, theta would have to be a quadrant 1 angle or a quadrant 4 angle on the unit circle, guaranteeing that the horizontal side will be positive. Therefore, it's going to be positive square root of 1 minus x squared. So with that in mind, since we're interested in the cosine of theta, now the cosine of theta would be the adjacent over the hypotenuse. So that would be equal to the square root of 1 minus x squared. So to finish this process off, we take the reciprocal of this and we get the derivative of our inverse sine function. So the reciprocal of this expression would be 1 over the square root of 1 minus x squared. This process can be repeated for all 5 of your other inverse trigonometric functions as well. I'd like to demonstrate this with one other, but you should acquaint yourself with the derivative shortcuts, and I will address this during class as far as where you can find them in the textbook, or rather your instructor will let you know where you can find them. So another example, let's do the inverse tangent of x. So step 1 of the process would be determine the original function. That'll be f of x is equal to tangent of x. Inverse tangent would be the inverse function to the tangent function. Differentiate this function. We'll get f prime of x is equal to the derivative shortcut for the tangent of x would be the secant squared of x. Then actually plug in the original function. We would get f prime of f inverse of x is equal to the secant squared of the inverse tangent of x. Now, just as we did in our previous example, there are actually going to be a couple different ways that we could approach this one. For the first approach, we'll do the exact same thing as what we did in the previous example. So theta will be equal to the inverse tangent of x, or equivalently, this means that the tangent of theta is going to be equal to x, or more specifically, this will be x over 1. According to right triangle trigonometry, or the TOA of SOHCAHTOA, the tangent is the opposite over the adjacent. So opposite side will be x, adjacent side will be 1. You now have two sides of a right triangle. Please do the natural thing. So a squared plus b squared is equal to c squared, or equivalently, that would be 1 squared plus x squared is equal to c squared. Because we're dealing with a hypotenuse, we will assume that the hypotenuse is never equal to 0. C would then be equal to the square root of 1 plus x squared. Now we are interested in finding the secant squared of this thing. Now the secant squared would be the hypotenuse squared over the adjacent squared. Or we could just say hypotenuse over adjacent and then square the result. So this will be square root of 1 plus x squared, quantity squared, or equivalently just 1 plus x squared. To finish our derivative, we would want to take the reciprocal of this. So step 4, the derivative of the inverse tangent function is going to be equal to 1 over 1 plus x squared. Now again, there are 4 other derivative shortcuts for our 4 other inverse trigonometric functions. I would say acquaint yourself with them. And please know that these derivative rules can also be combined with the quotient rule, the product rule, the chain rule, all the good stuff that we have. More on that in future videos.